Inside your veins right now, your white blood cells are actively manufacturing this incredibly unique, highly unstable chemical compound.
Yeah, it's essentially a biological tool, right? Used specifically to just hunt down and physically dismantle invading pathogens.
Exactly. And for decades, the idea of reproducing that exact chemical response outside the human body, well, it was a total logistical nightmare.
Oh, absolutely. Almost impossible to stabilize at scale.
Right. But recently, thanks to this deceptively simple process involving really just salt, water, and an electrical current, we've actually figured out how to bottle it.
It's pretty amazing how simple the ingredients are.
It really is. So welcome to today's deep dive. Our mission today is to unpack a really fascinating source provided by Era Organics. It's written by Nikki Chase, and it's all about this specific compound, hypochlorous acid, or HOCl.
Yeah, HOCl. And we're going to break down what it actually is, how it operates as an antifungal agent on a cellular level, and, why it might just replace half the toxic cleaning supplies in your cabinet.
Not to mention all those specialized skin creams, too.
Right, exactly.
Because to really hook you on this HOCl isn't some harsh synthetic laboratory invention. It is the exact same compound produced naturally by your own immune system.
Specifically your white blood cells, yeah, to
Right.
fight off infections.
Right. And to understand why this single molecule is gaining so much traction across completely different industries, we have to look at the manufacturing process.
Yeah, so the process is called electrolysis. When you take standard saline water, so just regular H2O and ACl, right?
This is salt water.
Literally just salt water, and you run a very specific electrical current through it, you force those molecules to break their existing bonds and rearrange themselves.
Which gives you the HOCl.
Exactly. You end up with HOCl. You are essentially taking the basic building blocks of the ocean and restructuring them to mimic the exact defensive secretion of a mammalian neutrophil.
A neutrophil, that's a type of white blood cell, right?
Yeah, it's the specific white blood cell that acts as your body's first responder to infection.
Okay, let's unpack this. Because to see why that restructuring is so effective, we really need to zoom all the way down to the microbial level.
Right, down to the actual cells.
Yeah, if we picture a fungal spore, something stubborn, like the trichophyton fungus that causes athlete's foot, or even just common household black mold.
Both very tough to kill.
Right. So think of that spore as a heavily guarded castle. The outer wall of that castle is made of these really tough materials, but more importantly, it has this built-in magnetic shield.
That's a great way to visualize the electrical charge of the cell wall.
Yeah, and traditional disinfectants, the synthetic ones, they usually carry an electrical charge themselves. So when you spray them, those charged molecules are sort of like clumsy battering rams.
Bouncing right off the walls.
Exactly. They hit that magnetic shield of the castle wall and just bounce off. They really struggle to penetrate the defenses. But HOCl, it's like a stealth ninja.
I love that. A stealth ninja.
Because it carries a completely neutral electrical charge. It just bypasses the protective barriers completely unnoticed, sneaks in, and then blows up the castle from the inside.
What's fascinating here is that this exactly mimics the defensive response of those mammalian neutrophils we talked about.
Oh, really? So our bodies use that same stealth tactic?
Absolutely. That neutral charge is the entire key. Because HOCl is electrically neutral, it doesn't trigger the electrostatic repulsion of the fungal cell wall at all.
It just slips right past.
Slips completely unnoticed past those external barriers. The cell membrane doesn't even register it as a threat until the molecule is already inside the internal structure of the pathogen.
And once it's inside, it initiates this process of rapid oxidation, right?
Right. Oxidation, in a chemical sense, is just the process of stealing electrons. The HOCl molecule starts aggressively ripping electrons away from the structural proteins and lipids that hold the fungal cell together.
Wow. And the source goes into detail about what it targets next.
Yeah.
It mentions this thing called the oxidative phosphorylation process.
Yeah, which sounds like a mouthful.
It really does.
Yeah.
But stripping away the jargon, that's basically the cell's internal power plant, right? Inside its mitochondria.
Exactly. So the HOCl doesn't just damage the exterior wall. By stealing those electrons, it literally disrupts and crashes the production line that the cell uses to generate energy.
It starves the cell from the inside out.
Serves it completely. And then it continues that structural dismantling all the way down to the pathogen's DNA and RNA.
It breaks apart the DNA.
It forces the DNA and RNA sequences to physically break apart. It literally unzips the genetic code of the fungus.
That's wild. So without intact DNA, the pathogen loses all ability to replicate or repair itself, right?
Yeah, the structural integrity of the cell membrane completely fails. The internal contents of the pathogen just leak out, and the cell dies almost instantaneously.
Just instantly upon contact.
Pretty much. The data shows that highly stubborn fungal strains, like Candida, they lose their viability in just a matter of seconds when exposed to an HOCl solution at only 100 to 200 parts per million.
Which is such a tiny concentration. And the physical nature of that destruction, it actually points to a massive evolutionary advantage for us.
How so?
Well, when we use standard chemical treatments or even, certain antibiotics, there's always that risk of pathogens mutating over generations to build resistance.
Oh, right, superbugs. They learn the chemical signature and adapt to survive it.
Exactly. But because HOCl physically ruptures the cell membrane and just shreds the RNA, the fungus can't build a resistance to it.
It's structural damage.
Right. A pathogen can't genetically mutate to survive having its literal architecture blown apart. It's a mechanical kill, not just a biological suggestion.
Which brings us to the inevitable comparison, I think. Because if the goal is a complete mechanical kill of a fungal cell, the immediate thought for most people is to reach for the heaviest, most aggressive industrial cleaner under their sink.
Oh, for sure.
Yeah.
Which, for the last century, has been bleach.
Right. Bleach. Sodium hypochlorite.
So here's where it gets really interesting. Because people have been dumping bleach on bathroom mold for decades. Are you saying they've been doing it wrong this whole time?
Well, yes and no. Bleach is undeniably effective at killing microbes on contact, but its chemical profile presents severe limitations when it comes to mold.
Because it's so toxic.
That's part of it. Bleach has a very low safety profile. It's highly corrosive, it strips the finish off of materials, and it off-gasses those toxic fumes that actively damage the human respiratory system.
Right. Everyone knows that harsh bleach smell.
Exactly. But the bigger issue with mold is the electrical charge. Mold walls contain chitin and cellulose, and as a biological entity, mold carries a negative electrical charge.
Okay, so mold is negative.
Yes. And bleach, because of its highly alkaline nature, also carries a negative electrical charge.
Oh, wow. So two negatives.
Physics dictates that two identical negative charges will repel one another.
Just like trying to push the negative ends of two magnets together, they physically refuse to connect.
Yep. Exactly. So when you try to saturate a porous surface, say drywall, exposed wood beams, or unsealed bathroom grout, with a negatively charged bleach solution, the negatively charged mold literally pushes back.
It repels it.
The bleach is electrostatically prevented from penetrating deeply into those microscopic pores.
So when you spray bleach on the wall, it's not even soaking in, it's just sitting pooled on the surface.
Just sitting on top. And the chemical reaction of the bleach strips the dark pigmentation out of the top layer of the mold spore. It turns it white or translucent.
Wait, so it just turns the mold invisible?
Pretty much. It visually disappears to the naked eye, so it gives you, the homeowner, this immediate illusion that the wall is pristine and the mold is gone.
But underneath the surface?
Shielded inside the pores of the wood, those deeper mycelial roots of the mold are completely unharmed. They're chemically protected by that electrostatic repulsion.
So they just wait for the moisture to return and then grow right back.
Exactly. It creates this behavioral loop where consumers keep using a product that isn't actually solving the root problem.
And breathing in toxic fumes while doing it.
Right. But HOCl fundamentally changes this dynamic. Because of its neutral charge, it faces zero electrostatic repulsion. It just flows freely into those deep microscopic crevices for a complete kill.
And it does all of this without bleaching the color out of your paint or releasing toxic fumes into the air you breathe.
Exactly. High effectiveness with a very high safety profile.
Which unlocks this massive spectrum of applications. I mean, going from scrubbing black mold in a basement to treating human skin seems like an impossibly huge leap. But the source outlines how this exact same chemical is used in skincare.
Oh, dermatologists use it constantly.
Right. For things like athlete's foot, persistent fungal acne, and even early-stage nail fungus.
It's incredibly gentle on the skin.
Yeah, the protocol is just to apply it evenly to clean, dry skin 2 to 3 times a day, usually at like 50 to 200 pH, and just let it air dry. No alcohol, no fragrance.
Just spray and dry.
But that begs the question. If HOCl is powerful enough to violently rupture the cell walls of black mold, why doesn't it melt our skin or, destroy plant leaves when we spray it?
If we connect this to the bigger picture, the secret really lies in the pH.
The pH level.
Yeah. Commercial HOCl solutions formulated for skin are meticulously calibrated to sit at a slightly acidic pH, typically ranging between 4.5 and 6.5.
Which actually aligns perfectly with human skin, right? Because we have that natural acid mantle.
Exactly. The acid mantle is our skin's slightly acidic barrier. It's our first line of defense. By formulating HOCl to match that pH, it acts like chemical camouflage.
So our bodies don't even register it as a harsh chemical.
Right. It preserves our barrier function while delivering its antimicrobial payload directly to foreign invaders. It operates in perfect harmony with mammalian biology.
That's incredible. The applications go way beyond human healthcare, too, like agriculture and hydroponics.
Oh, hydroponics is a huge use case.
Right, because in hydroponics, plants grow in water instead of soil. And that constant moisture creates a really susceptible environment for waterborne fungi.
Specifically, this water mold called Pythium, which causes devastating root rot.
Yeah, and normally fighting a fungal infection like that, or like powdery mildew, means dumping harsh synthetic chemical fungicides everywhere.
Which leaves toxic residues on the food you eat.
Exactly.
Wow.
But with HOCl, hydroponic farmers are just dosing their massive water reservoirs continuously and at incredibly low concentrations.
Really low, usually just 2 to 5 parts per million.
2 to 5 parts per million, that's almost nothing.
To contextualize that, 2 parts per million is roughly equivalent to placing a single drop of HOCl into a standard 13-gallon kitchen trash bag filled completely to the brim with water.
Wow, 1 drop in a whole trash bag of water.
Yeah, and even at that microscopic concentration, the continuous presence of HOCl in the water is enough to constantly oxidize and prevent Pythium spores from taking hold.
And it leaves no chemical residue, right?
Yeah.
Because it just breaks back down into simple saline water once it expends its energy.
Exactly, just salt and water.
I mean, it sounds like the absolute perfect mechanism. It's a non-toxic ninja that kills mold better than bleach. It's gentle enough to spray on your face, and it protects our food supply.
It really does.
But if it's this reactive and safe, there has to be a catch, like an Achilles heel to the whole thing.
There is a catch.
Uh-huh.
And it comes down to stability, storage, and shelf life.
Right, because the exact chemical delicacy that makes it so safe and reactive also makes it incredibly unstable.
Profoundly fragile, yeah. The HOCl molecule degrades incredibly fast when exposed to 3 primary things: ultraviolet light, ambient heat, and just oxygen in the air.
So you can't just leave a bottle sitting on the counter in the sun.
Definitely not.
Yeah.
The UV rays literally cleave the chlorine bond. The active ingredient just unravels.
Wow, it just falls apart. And what about the pH? We talked about it needing to be between 4.5 and 6.5. What happens if it climbs above 7.0?
That's when it gets tricky. If it hits an alkaline state above 7.0, the HOCl molecule converts into something called a hypochlorite ion, OCl-.
And why is that bad?
Because the moment it turns into a hypochlorite ion, it gains a negative electrical charge. It loses the neutral stealth capability that made it a ninja in the first place.
Oh, so it basically turns back into a clumsy battering ram.
Exactly. Suddenly, it suffers from the exact same electrostatic repulsion as bleach. Its effectiveness just plummets.
So what does this all mean for someone actually trying to use it?
It means you can't treat it like a normal cleaning supply. You can't just buy a clear spray bottle of HOCl and leave it in a hot car for a year.
Because it'll just turn back into useless salt water.
Exactly. It requires airtight, completely opaque packaging. It has to be stored between 50 and 70 degrees Fahrenheit. And even under perfect conditions, its shelf life is generally only 1 to 3 months.
Just 1 to 3 months. That's so short.
This raises an important question about consumer awareness. It really forces the buyer to be vigilant. You have to check expiration dates.
Right, and probably look for companies that provide, like, actual laboratory testing data to prove it has the right ppm when it ships.
Yes. You have to treat it more like a perishable grocery item than a bottle of Windex.
And the source has one very crucial safety warning we have to mention. While HOCl on its own is incredibly safe, it is still a highly reactive chlorine compound. It must never, ever be mixed with ammonia or bleach.
Never. Mixing it with the high alkalinity of bleach or ammonia will cause severe adverse reactions. At best, it completely neutralizes the acid. At worst, it creates toxic, hazardous fumes.
Right, so just let it do its thing on its own.
Exactly. It requires a mental shift. We're so conditioned to believe that if a cleaner doesn't smell like burning chemicals, it isn't working.
Oh, totally. We associate that toxic smell with clean.
But this compound proves that chemical strength doesn't have to equal toxicity. We just have to respect the delicate balance of biological chemistry.
That's a huge takeaway for you listening today. You now understand the actual mechanics of this biologically native, electrically neutral fungal assassin. It really is an assassin.
It is. We zoom down to the cellular level to see how it bypasses those electrostatic defenses and physically rips apart a fungal spore's power plant through rapid oxidation.
And we broke down the physics of why dumping bleach on porous mold is just a surface-level illusion.
Right, leaving the deep roots perfectly intact. And we saw how, by matching our skin's acid mantle, HOCl can treat things like fungal acne without causing massive inflammation.
While also protecting hydroponic farms from root rot at just a few parts per million, without leaving any toxic residue.
But you also know the trade-off. It's a fragile, unstable biological tool. You have to check those expiration dates, keep it out of the heat and UV light, and respect its shelf life.
It's a trade-off for using a deeply science-backed mechanism that works with biology instead of against it.
Absolutely. Whether you're dealing with a damp basement, an annoying skin irritation, or a stubborn houseplant, you now have a highly effective tool to consider that won't fill your home with toxic fumes.
Which is a huge win, definitely. And that leaves us with a final thought for you to chew on as we wrap up. We started this deep dive by establishing that HOCl is the exact chemical response manufactured by the white blood cells inside your own veins to fight off pathogens.
Right.
And we've successfully figured out how to replicate and bottle that exact localized immune response using nothing more than salt, water, and electricity. So that makes you wonder, what other natural biological defense mechanisms are quietly operating inside of us right now, just waiting to be understood and synthesized,
Yeah.
potentially making harsh synthetic chemicals a thing of the past?